right, so most of you guys are, at least at this point, familiar with what ROS is, or probably have heard about it. So what I suggest is on the ROS wiki page, you have a set of tutorials that you can easily um, learn ROS from, like the basics onwards to the advanced. And I honestly think that out of all the tutorials you can find online, starting here is probably the best if you want to quickly grasp the core concepts of ROS. So there's a set of beginner level tutorials, and then there's a set of intermediate level tutorials, and it pretty much covers the important basic fundamentals of ROS. And if you run through each of these tutorials, I suggest starting maybe, like, even at this stage, if you just finish the basic level tutorials, that should give you a lot of insight into how to do your projects and stuff like that, right? So I suggest, if you are not that familiar with ROS or haven't used it before, maybe start going through this now itself, because I think we are planning on starting your projects sometime, I think next week or the week after. So this is a really good time to brush up your ROS knowledge, right? So today, what we'll be doing is setting up a couple of sensors using ROS and really understanding some of the core concepts behind ROS, right? So just to make today's tutorial session go a little smoothly and for everyone to be familiar with the terminology that we'll be using, I'll just quickly run through some important aspects of ROS, right? So ROS stands for Robot Operating System, right? And it's often referred to as a meta operating system. So we all know about, like, typical operating systems like Windows or Linux or whatever, but ROS acts on top of already existing operating systems and kind of helps you set up either sensors or control algorithms, and help different aspects of your robot basically talk to each other, whether it's sensors talking to the controls, or you just getting information from the sensors, or you implementing some form of control, or some form of processing. All of that can be handled with ROS, and the great thing about it is that it works on top of any other. It adds an additional layer on top of any other operating system, and it allows you to communicate across different computers, different process architectures, different operating systems, right? So for example, like in my PhD project, I have a robot that has a ARM processor running on a Jetson, NVIDIA Jetson board, and then I have also Upboard, which runs an which has a Intel Atom processor, and then I also have so both of those run Ubuntu, and then additionally I have a tablet which is running Android, which I use to get cellular GPS data, and I'm getting all of these different operating systems, different processor architectures, all of them working together using ROS. So ROS really makes your life so much more easier than if you didn't have it, right? So if you want to kind of stay in robotics and maybe in the future have a career in it, I think learning ROS at this stage is pretty helpful. So like I said, ROS is a meta operating system, and there are a few core concepts that might be helpful, especially in today's tutorial. So how ROS really works is so the different so the first concept in ROS that you need to understand is what we call a node, right? Or so a node. By the way, apologies for my weird handwriting. I'm using my mouse to write on this, so it might be a little weird. So anyways, so a node is basically some form of like executable, right? In the ROS framework, a ROS node is basically an executable that either provides information or takes in information to kind of process it, right? So think about it as, for example, let's say you have a robot, right, which has a bunch of sensors. Let's say it has two cameras, one camera over here and another camera over here, for example, right? So, and then on the robot, you have some sort of processing unit, some sort of computer that has to take images from this camera and process them, right? Also, the robot has wheels, right? So there is some form of control that has to be executed. So this computer then has to communicate with the motors and the motor controllers and get the wheels moving, right? So each of these components in your robot, or each of the aspects of these components in your robot will be handled by a separate node. So your camera will have its own node, right, to get sensor information, right? So that will be node 1, which will be providing camera sensor information, right? And then you'll have another node for this camera, which will be providing more sensor information, right? And then you'll have another node, for example, handling, so this will be node 3, this will be node 2. You'll have another node handling control information that comes from the computer to your motor controls, right? So a node is basically this executable unit within ROS that helps you get information flowing from one aspect of your robot to the other, right? So that's what a node is. So for example, if you had one node here, it will be giving information to another node, right? And that information is transmitted through what we call a ROS topic. So a topic is basically, it defines the information, the type of information that is being transmitted. So for example, if node 1 is a camera node, the kind of information that we want to transmit are images, right? So you will have a ROS topic that will be of type, which will have messages inside of them, right? So a message is basically some type of data structure, right? Data structure that will basically carry this image information, right? So we discussed what image data looks like in the last couple of tutorials, right? They're just like a matrix with, if it's RGB image, like 3 channels or whatever. So you will have a ROS message type that will encapsulate all of this information, right? So your topic is what we say publish that information. So you'll publish that information from your sensor, and whoever is listening to that information, right? Whoever takes in that information is called, is said to subscribe to that information, right? So a node that publishes information is called a publisher, right? And a node that listens to information is called a subscriber, right? So a simple example, like I said, you might have a camera publisher node publishing a camera topic with messages which have a data structure that can have image data in it, and then you have a second node that acts as a subscriber listening to that camera information and can then process that camera information and do whatever it can with it, right? And sometimes some nodes can both publish and subscribe at the same time, right? They might say subscribe to some topic and then publish to another, and so on, right? So really what you end up with is with a network of nodes, right, that can kind of make your life easier when you're dealing with a lot of sensors, a lot of different operating systems, and a lot of aspects of robotics, right? So ROS really makes your life easier when you do that, right? When you use it. So what really handles all this communication, all this networking, is what we call your ROS core or your ROS master, right? So at this point, I'm not going to go into super in-depth detail about all of this stuff. I'm just giving you guys like a bird's eye view of the whole system, so that you guys can kind of do the tutorials easily, or at least understand what's going on, right? So the ROS core is basically what's kind of, think of it as like some sort of administration, right? So it handles all this communication, right, between subscribers, publishers, and subscribers, and so on. Okay, so before you get these nodes running, you always have to start something called a ROS core or a ROS master to make sure that all of this communication and running of these ROS nodes is handled smoothly. Okay, so that's really a quick overview of ROS. Are there any questions before we move on to the next section that maybe I wasn't clear in explaining? Okay, since no one is saying anything, I'm gonna assume everyone is clear with the basics of ROS, right? I also suggest, whether you've done ROS before or not, just go through these tutorials again so that you can quickly brush up your knowledge before we start on your projects, because you'll be using them. Can everyone still hear me? Am I still online? Okay, sweet. All right. Okay, so now that we have a basic idea of ROS, let's jump into question 3, right? So in question 3, what we are doing is we're going to set up a ROS node called USB cam, right? So this node helps you interface with USB cameras and your computer, right? And also your webcam as well, right? So when I was explaining what a ROS node is, one of the most important uses of a ROS node is it acts as a driver, right? So we all know, I hope know what a computer driver is, right? So a driver is basically a piece of software that helps your computer's operating system to communicate with external hardware, right, or internal hardware, right? So what's one major use of a ROS node is it acts as a driver to connect, say, an external sensor. So again, if you're talking about a camera or something like that, it acts as a driver between it accesses the drivers of your operating system and then converts that information into a data structure that is easy to process and understand, and then publishes them, right? So ROS really helps you interface with a lot of sensors, get your operating system, get your computer interfacing with different sensors, whether it's cameras, lidars, RGBD cameras that you learned about today, or whatever, right? So and then what you do is, once it publishes that information, you can process that in a separate node, and then you can so how you would do that is you would write a subscriber who would listen to that information, process that, and then maybe publish another set of information, say the control information for the wheels of the robot or something like that, right? So that's really how ROS, using ROS in like to get all these different aspects of robotics to kind of mesh together and work together really happens, right? Most of this, like once you start doing your projects, you'll be using a lot of these concepts, so you'll be even more familiar with it. All right, so let's do question 3. What you're supposed to do is, you hopefully at this point all of you have set up Ubuntu and ROS on your systems. If you haven't at this stage, you really should, because from this point onwards we'll be doing a lot of things on ROS, and when your project start, you'll certainly be doing a lot of things on ROS, right? So here I provided a link about setting up ROS and configuring it in your environment. Okay, so assuming that you guys have set up your ROS environments, what we want is to clone this GitHub repo that has this USB cam ROS node, right? So how you do that is you go into your Catkin workspace. I hope you guys know what a Catkin workspace is. Okay, first of all, can I know if you guys have set up ROS on your systems? We discussed this last week. Could I have just 1 or 2 people just give me some feedback about that, whether you guys have set up ROS or not? Okay, great. Okay, awesome. Okay, good. Thanks, guys. So then you guys should know what a Catkin workspace is. So a Catkin workspace is like a uh, C++ and Python building environment that allows you to build your ROS nodes and so on, right? So I'm going to go into my source folder in my Catkin workspace, and I'm going to clone this GitHub repo, which has the USB cam node in it. I say git clone, and I'm cloning it. So it will download that ROS node. So if you go to that link, you'll see all the files inside of it. So it will also give you information about how to use it in usually in the GitHub repos. So there's a wiki page for the USB cam node, which gives you how to use it, what topics are being published, what parameters we can really control, and so on, right? So I've downloaded now the GitHub repo. So what I'm going to do is I'm going to say catkin build, which builds that ROS node that we just downloaded. Once we do that, just for your terminal to be refreshed and take into account the node that we just built, we are supposed to run source devel setup.bash. Right. So what we are doing here is we are reloading what we call the bash RC, which has all the paths to your ROS libraries and things like that, so that your terminal can access them, right? So you can either close your terminal, open it, or just run source devel setup.bash, or you can say source your bash RC file, right? That would refresh your bash as well. Okay, so now we built the USB node, right? So what we're going to do now is we're going to say ROS launch USB cam test, right? So what we are doing here is now we are launching the ROS node that I was talking about, right? So how you start this ROS node is you have something called a launch file, right? A launch file, which controls basically basically which node to launch, and also what parameters we need to apply onto that launch, right? So you can see that when you go into your Catkin workspace, go into your source folder and find USB cam, the file you just downloaded, and it should have a folder called launch, right? So when you open it, you see this launch file called USB cam test.launch, right? When you open it, it will give you what we call a launch file, right? So launch file is just a basic configuration file that tells you which node to launch, and also you can pass through parameters and things like that that will help you launch it, right? So here we are setting the image width, image height, which video device to launch, and so on, right? So how you launch it is you say you say ROS launch, and then the name of the node, which is USB cam, and then you have to give the name of the launch file. So the name of the launch file is USB cam test.launch, which I just showed you guys here, right? Which is just a text file which has all the information on which node to launch and so on, right? Again, all of these, if all of this sounds like Greek to you, just make sure you go through these tutorials and on the ROS wiki page and get yourself familiar with most of what I'm saying, right? All right, so if I launch this, you can see that it launches my webcam on my laptop, right? So again, this is basically me accessing the webcam through ROS, not through Zoom or anything like that, right? So for example, if you had like an external webcam, the thing is usually I do this with like an external webcam, but I left all my sensors back in uni, and I haven't been to uni in a while. So you guys can try this as well. It will access the webcam of your laptop. But if you have like an external USB camera, you can plug that into your USB and also launch this launch file, and it will access that webcam, right? So let's say you have multiple cameras, multiple webcams, say an external USB webcam, your internal laptop's webcam, and so on. How you would pick which webcam to open is you go to the launch file that I was telling you about, and here you can see that the video device parameter that I've set is dev/video 0, right? So let's say you had a separate, you had multiple cameras, right? Just USB webcams attached to your laptop or whatever on top of your internal laptop's USB camera. All you have to do is change this number and it will open a separate device. So 0, 1, 2, whatever, right? And you can basically check what devices you have using this command. Yeah, you can say ls usb. That will give you all your devices, right? And here you can pick which device. Let's say you had a external webcam connected, you can pick what that device number is, and then just all you have to do is set it up here and change this number here, and you can access different cameras, right? So that's really it for this tutorial. The important thing is you guys should try this yourselves using your own computers, or it will be nice if you also have maybe an external USB camera that you can attach and then switch between the internal camera of your of your laptop and the external USB camera. Again, another thing, a couple of commands that you can use to kind of understand what's going on in ROS some more. Remember I told you guys about like ROS topics. Those are basically the information that's being published, right, by your node. You can look at what the list of ROS topics that are being published by your devices, right? So how you do that is in your terminal, you type ROS topic list. Sorry, you type ROS topic list, and it will give you a list of all the topics that are being published, right? So you can see here there's one called USB cam /image raw, right? So that is generally where your image is being published, right? So there's another important command called ROS topic info, right? That will give you information about any of these ROS topics. So what you have to say is ROS topic info and give the name of your ROS topic. It will give you information about the information. It will give you information about the type of ROS topic. So it says here it's of the data structure sensor messages /image, right? And it will give you what node is publishing and what node is subscribing right now, right? So right now we have this window here that's subscribing. It's called image view. It's another node in ROS, and you can see that it's subscribing to this image, and that's how it's displaying this image. Now if I close this, I can launch that node separately. So the way you launch it is by typing ROS run image view, ROS run rqt image view, That command is given in your tutorial as well. So if I run this, it will open up what we call image view, which helps you see image data that's being published. So here you have to pick the right topic. So the topic that's publishing your image data is USB cam image raw. If I select that, you can see that my face pops up again, right? So these few commands are super important, like ROS topic list to see what are the topics that are being published. ROS topic info gives you information about that topic, what it's publishing, what node is publishing it, what node is listening to it, subscribing to it, and also the type of messages that are being published. Now a third really important terminal command is ROS topic echo. So ROS topic echo gives you allows you to echo the information that's coming. So if you want to actually see the raw information that's coming, say from this topic, you say ROS topic echo, and you give that the name of your ROS topic that you want to see, and you can see now that you are getting a whole bunch of numbers. So this is basically the raw image data that's coming from that ROS topic. right? So these numbers are basically the matrix that forms the image that we've kind of manipulated in the previous tutorials, right? So again, just to summarize, some important terminal commands when you're dealing with ROS is ROS topic list, ROS topic info, ROS topic echo, right? And there's a whole series of commands like that that will help you kind of like see what's going on. So again, once you go to the tutorials and get familiar with ROS, you'll be using them a lot, right? So these beginner level tutorials are really great for getting the basics that you need to, get started with your projects and stuff. All right, so that's the end of tutorial 2 and question 3. So are there any questions regarding this? Okay, so no one's saying anything, so I'm assuming that there aren't any questions, and we'll move on to tutorial 3. So guys, go to your UTS Online, and under Learning Material Week 3, you should have a ROS bag to download and a tutorial 3 PDF. So go ahead and download that stuff, and I'll give you guys like 5 minutes to get everything ready, get the PDF and get the tutorial RGBD bag, ROS bag, and I'll kind of jump into the theory in a bit. So I'll give you guys like 2 to 3 minutes to quickly sort that out. In the meantime, if there are any questions, just feel free to just type it on the chat.